Alright, so we're going to start 7.6. This is the last and final unit. It's the present value of an ordinary annuity. So the money you invest right now to earn a certain amount of money in the future. So let me start you off by showing you the timeline for this, which is the best way to represent anything. 0. Let's use the previous example as the same one. For 10 years. And let's say you put in the $1,000 you invested last time. So the 1,000 you invested last time. This is the 9th year, it's the 10th year. And this $1,000, make that line a little shorter. This $1,000 has earned, but the interest was 5% last time. So 1.05 to the power, and this has earned it for 10 years now. This has earned it for 10 years. And now you have to backtrack. So this 9th year, the 1,000 has earned it for the 9 years. So I use negative 9, negative 10. You're counting down now. The 8,000 similarly has done it for 8 years. And we'll skip all the way down to 1. Well, 2 and 1. So here's 2, here's 1. Let me erase it 0 for a second. Alright. So 0's here. This is 2. So this 1,000 has earned it for now 1, 2, first year, second year, 2 years. Negative 2. And this one finally has earned it for 1 year, 0.05 or negative 1. So as you can see, it's counting down 10, 9, 8, 7 to 1. And this is the timeline. And using the timeline, you can get the formula for present value, which present value is equal to the regular payment into 1 minus 1 plus the interest to the power of n, negative n. Because if you follow the derivation, it'll make more sense to you. But in this video, there's not enough time, so that's the main formula for present value. And you'll use this formula for any present value question with it involving an annuity. Alright, so let's try a simple question. Alright, so let's take a look at this question. When Mr. Patel retires, he hopes to receive $10,000 semi-annually for 20 years. His investment plan pays on average 6% compounded semi-annually. How much money should he invest right now to make sure he receives his $10,000 every 6 months? So let's start this off by representing everything with a number line, because personally I feel it's the best. So 0. Here he just has his 10,000, and in his 20th year he will have, because it's compounded semi-annually, he'll have the 10,000, and this has been compounded 3, because this is semi-annually. The I would be divided by 2 for the 6%. So 10,000 times 40 to the power of 40, negative 40, because it's every 6 months. And so the compound period is 40 and negative 40. So this 10,000 has been compounded for 40 periods. Likewise, say his 10th year, the 10,000 has earned interest for 20 compounding periods. So there's my timeline. And now I'll just use the equation P.V equals R into 1 minus 1 plus I. And in this case, we're going to divide that by 2 because it's semi-annual. Power n, and multiply that by 2 because it's semi-annual. And this is all over the interest rate divided by 2. And so now we just got to sub in the values. 10,000, which is the amount he wishes to receive, into 1 minus 1 plus 0.03, 0.06 divided by 2, into negative 40. Sorry, this was negative n. So into negative 40, all over 0.03. And this is equal to the 231,147.72 dollars. So therefore, for Mr. Patel to receive his payments, he must invest $231,147.72 right now. And that's that. That's how you do present value.